Please welcome Mr. Ram Chand with big applause.
Thank you. Hi, everybody, and good afternoon in Japan. I'm Ram, and I'm speaking from Tel Aviv, Israel, where it is morning. And my talk is going to be about PySnooper. PySnooper is an open source project that I've developed. It's a debugging tool. And in this talk, I'm going to tell you all about it, everything that might interest you. So PySnooper is an open source project that I created. I'm going to tell you about myself, and I'm going to tell you about PySnooper. But first, I want to brag that it's been one of my most successful ones. Here's the project on GitHub. Here's the GitHub page, and you can see that the project got many stars. There are 13,000 stars. Lots of people visited this repo, and I released it a year and a half ago. And it really amazed me to see how many people really liked this repo and started it and forked it and shared it and tweeted about it. And I got lots of contributors. I have 23 contributors. So I'm going to tell you all about it. And after describing the solution itself, I'm going to talk a little bit about making a popular open source project. But first, about myself. My name is Ram. I'm a longtime Python developer. I'm known mostly for my big open source projects, which are PySnooper and Python Turtle. I've contributed to a bunch of big projects like CPython, Django, PyPy, Matplotlib, and others. I do Python workshops. I organize PyWebIL, which is the Israeli Python community. And I'm a member of the PSF and the EuroPython Society. Feel free to ask questions during the talk, everybody. If you have questions, if you have anything that's unclear, feel free to ask them in the chat, and I'm going to see that, and I'm going to answer your questions. So really feel free to interrupt me in the middle. So here are a few things I'm going to talk about. I'm going to talk about debugging with a classic debugger. I'm going to talk about why people use print statements and log statements for debugging. I'm going to talk about how PySnooper is a compromise between these two things. I'm going to talk about how to use PySnooper to debug your code. I'm going to talk about how to make your open source project popular. And I'm going to also show another debugging tool called PuDB. Okay, so let's get started. So before I explain about PySnooper, I'm going to talk a little bit about classic debuggers. Okay, so this is my debugger. It's called Wing IDE. You have probably never seen it before, but you probably know PyCharm. So it is the same thing as PyCharm, just a different brand. And here I have a piece of code. Now, I'm debugging, which means that let's say there is a bug in my code, and I want to figure out what's happening. And I'm looking at my code, and it seems like it should be doing the right thing, but it's not. There's a bug. So I want to understand what's going on. And I really love to use a classic debugger. So now, okay, first I'll explain about this code. This is just a simple function that I found online. And what it does is it takes a number and it converts it to bits. So for example, now I gave it the number 6 and it's converting it to bits, to binary, which means 110. Here's the output, 110. So let's say I wanted to debug this program. So I could put a breakpoint right here, for example. Then I would run the program. And then the debugger would stop on that line. And then I could go forward. And when I go forward, I can always use the debug probe to check the value of variables. I can see that the variable number is equal to 3. The variable remainder is equal to 0. I can step through the code, really see what's going on. Super comfortable. I can step into functions, step out of functions. I can set conditional breakpoints. I can set watch expressions, do all kinds of fancy debugger stuff. So I really love to use debuggers. I think they are very convenient. But when I started working with Python professionally, I found that so many people don't really use these kind of debuggers. People use PyCharm, but they usually don't use the debugger of PyCharm. And for me, this was very surprising because this is such an awesome tool. Why wouldn't people use it? And the answer to that question is that debuggers look simple when you're working on just a simple file on your computer. But if you work for a big company and you're working on a serious project, there are maybe hundreds of Python files, and they are in a project that is diluted and that is not run on your computer, but on a separate computer or in a Docker container or on a VM or in a different country or on a different operating system. And it's tough to get the debugger to connect to that kind of setup. It is possible, I've done it. It's possible both for Wing IDE and for PyCharm, but it requires a lot of setup, and most people don't want to spend the time doing that setup. So what most professional Python developers end up doing when they debug is something like this. Okay, I just put a bunch of print statements in the code. And now if I were to run the code, now when I run the code, I see that there's a text of entering loop and loop run, and I know the loop ran 3 times and then ended. And then I can add stuff to these print statements. For example, I can say I want to see the value of the variable number. And now when I run the code, it's going to show the same thing, but also I see the value of the number variable. So that's useful. What people end up doing is going back and forth and figuring out that maybe they put the print statements in the wrong location, and then they move them around and they put them in a different location, and maybe they decide to expose different variables. So I have mixed feelings about this method. I think that on one hand it's very beautiful, and on the other hand it's very ugly. The ugly part is because it is so manual. You have to go manually and put these print statements one by one. You have to decide where you want to put them in advance. You have to decide in advance which variables to expose. And then you have to run them, run the code, and see if the text you saw printed wasn't exactly what you expected. So you go in and you put the prints in a different place and you try to run it again. And if you're working on a big, complicated project, this running again is annoying because there could be a long build process, and it could take you a long time to reach the state that reproduces your bug. So that's why it's ugly. It's very annoying to do this back and forth of adding print statements. But it is also a beautiful method. And what's beautiful about it is that it just always works. I said earlier how it is so difficult to set up a debugger in a corporate environment because it's running on a different machine and you have to do remote debugging and connect to it and set up maybe an SSH tunnel. And that's such a drag. But print statements or log statements, which are the same or writing a file, that just always works. It's very reliable, which is why people have used it for many decades. So I said that I've spoken about the classic debugger, and I've spoken about why people use print statements and log statements for debugging. So now I'm going to explain how PySnooper is a compromise between the two. So I developed PySnooper a year and a half ago when I was frustrated with the current state of debugging. And I thought maybe it's possible to do a compromise, something that is easy and reliable like a print statement, even in complicated setups, but gives more information similar to a debugger. So that's what PySnooper is. Let me demonstrate to you how I use it. I'm going to delete the print statements, and I'm going to import PySnooper, and I'm going to do a PySnooper.snoop. Right? Just added a decorator to my function. And now when I run the file, I get this. Okay. What is this? This is a huge text dump showing everything that happened in the function. Now, at the end, there is the same output that there was before, 110. That's the output of my code. But we've got all this text, and this text is an automatic log of what happened in the file. So like if we read it, we see at the beginning, it tells us which source file is running, and then the starting value of the variable number. And then it just goes over each and every line of code saying this line ran, now this line ran, now this line ran. Now this is a new variable that got declared. Each and every line it just prints exactly what happened. And every time a variable got modified, it prints the new value of that variable. So it's an automatic way of saying just put prints everywhere, exposing everywhere. You get a huge dump of text, and then you can put it in a text file. You can grab through it, you can search, you can analyze it, and you can use it to figure out what's going on in your code. So that's basically what PySnooper does. That's the most simple usage. It has lots of advanced features. You can mostly read about them on the GitHub page. There is when you go into the GitHub page, there is a list of features. There is an advanced usage page where you can see documentation for everything. But I'm going to show you like maybe 3 features that are important. Okay, so when I decorate with Snoop, I've got a bunch of arguments. You can explore all of these arguments, but I'm going to show you just the most important ones. The first one is I can tell it to write to a file instead of writing to standard output. So that's useful if the code is not running on the shell. You can give it a file, you can give it a logger, you can give it any callable that processes a stream of text. So that's one thing that's useful. Another thing that's useful is you can set up watch expressions, just like a debugger. So I can say, please watch the len of bits. There is a list called bits. I want to get a watch on the length of it at each point. Let's now run the code. I ran it again. It looks the same, but there is something else. Every time the length of the bits list changes, we're going to get an entry for it. For example, here the length changes. So now it tells us that the new length of the list bits is 1. So we can put any kind of Python expression in that watch list, and it's going to watch it for us, and it's going to report to us every time it changes. So that's another useful thing. Another useful parameter, and this one I cannot demonstrate in this example, but I will just talk about, is depth. By default, depth equals 1, which means that PySnooper gives you output for every line that runs in your function. But if you do depth equals 2, it's going to give you output for every line that is run by a function that is run by your function, right? It goes 2 levels deep. If you type in 3, it's going to go 3 levels deep. You can really quickly, like if you type in 4 or 5, it can be a huge text dump. I found that very useful. I've often just done it like 1,000, depth 1,000, just to see everything. And that was pretty cool. The text dump was huge, but I was able to search through it. And the deeper parts are indented. So it's easy to see when it goes deeper and when it goes back to the previous stack frames. So these are a bunch of features. There are more features that you can see on the GitHub page in advanced usage. Okay, so I've spoken about how to use PySnooper to debug your code. Now I have 2 more things I want to talk about. And I remind you, if you have questions, feel free to ask them in the chat, and I will speak about whatever you want. Okay, so the next item is, let's talk about making a popular open source project. So I created PySnooper 1.5 years ago, and it's gotten real popular. I posted on Hacker News and on Reddit. I got lots of upvotes, and it went viral. And that's why it has 13,000 stars, almost 1,000 forks. Lots of people watch it, lots of people contributed to it. It's been pretty amazing. I was very happy when that happened. And I know that lots of people are interested in open source and making their own popular projects. So I'm just going to share whatever I can to maybe help you make your own projects more successful. So the most important thing that people from the open source world will forget is marketing. If you want to make your open source project successful, you really have to make it enticing and easy for people to understand what it's about. So the GitHub page is pretty much the homepage of your project. So it's important that when people visit it, they really get very quickly an impression of what's going on. So for me, I have this tagline here saying, never use print for debugging again, which basically lets you know what the project is about. And there is a Readme is so important because that's like your homepage. This Readme is actually longer than what you would usually want. But here I have an explanation of what PySnooper is and what is the pain point that it's solving. And a very important part of the Readme is the example. You gotta give an example of usage, a quick start, as soon as possible. And the example I've shown here is the same thing I've just shown to you. It's really important to put that out there. The thing that you have to remember when you're writing a README for your open source project is that people are impatient and they're very busy. They have maybe 30 seconds. They will look around at your page and they will see if it's interesting. They will find out more. If not, they will leave it. So it's your job to get that information to them front and center so they can make a decision. So much of the success of your project is going to be determined by how good your README is. The next thing you want to do is you want to post to Hacker News and to Reddit. Let's see the threads. Okay, so I posted to Hacker News. It got lots of points. You can see it's a year and a bit ago, a year and a half. You should post to Hacker News, to Reddit, and to get a few of your friends to upvote. It doesn't always help, but give it a try. And if it reaches the front page for even just a little tiny bit, then more people are going to see it and more people are going to upvote it. And then it can go viral. And what happened for me with PySnooper is so many people that came from Hacker News started that it got on the GitHub trending page. GitHub has a page called Trending, which shows the repos that have the most stars today. And once so many people started the project, it got on the trending page. And because it was on the trending page, more people saw it on the trending page, so they clicked it and started again. So it was another viral cycle. So just kept on going. And then people saw it there and tweeted about it and then retweeted. And David Beasley tweeted about it and then it blew up. So when it starts to become viral, things just happen by themselves. And your only responsibility is to make it enticing, make a nice README, and post it at a bunch of places at the same time. So that's the advice I have to give to you to make your open source project popular. And the last thing I'm gonna talk about, or you know what? Before I talk about PuDB, I'm gonna talk about how PySnooper works. So that's something that people ask me, what is this magic that lets PySnooper output or make an automatic log of your function? How does it know which line is running? How can it tell when the variables got changed? So I'm gonna show you this magic. I'm gonna step into PySnooper code right now. Oops. Okay, I'm stepping into PySnooper code. By the way, feel free to dive into this code on the GitHub page if you want to implement features or fix bugs. I'll be happy to have you as a contributor. Oh, you know what I should say? Okay, I'm going to talk about the contributors later. Anyway, so this is PySnooper code, and there is lots of code here, and lots of documentation, lots of details. Okay, so I'm not going to talk about the whole thing. I'm just going to talk about the very heart of the program, and that's sys.setTrace. And here is the line. This is the magic line that makes everything happen. This is the line in PySnooper that makes it work. Sys.setTrace is something that comes with Python, and it is a tool for you to add a trace function. It basically tells Python, please use this function I wrote, in my case, self.trace, as a trace function, which means please call it every time you run a Python line with the full information on which line ran and what is the current stack frame. And in this function, I get the arguments of the frame and the event and the arg. And then I use my own logic to do what I want, which is to print information about the line that ran. Now this sys.setTrace trick, this is basically how any debugger is written and how any code coverage tool is written. If you use coverage tools like coverage.py, which tells you which lines of your code ran, they use the same trick I did. They use the same sys.setTrace, except they have different logic in their trace function. Their logic is look at the lines that ran and update them in our database of lines that ran and did not run. And for a debugger, the logic is going to be different. The logic in the trace function is going to be look at the line that ran. Is it line 78 of file foo.py? If it is a breakpoint, please break. If it is not a breakpoint, please don't break. So you just put the logic that you want in your trace function. You can make a debugging tool just like I did. So that's it about how PySnooper is made. And I'm just going to say a couple of things about contributors. So I posted PySnooper a year and a half ago, and I got a bunch of contributors. And the most prolific one was Alex Hall. He wrote a lot of code, and he also reviewed that of other people's code, and also reviewed my code and other people's code, and it was very helpful. So he contributed a lot, and lots of other people wrote code, wrote pull requests, reported issues. Okay, so if we look at the pull requests, lots of people made pull requests, and we reviewed them. Alex did lots of work reviewing them, and we added more features and fixed more bugs. I am careful not to add too many features because I like to keep it as a cute little toy. I don't want it to get to be a complicated debugger. Okay, so enough about PySnooper, and now for something completely different. I'm going to talk about PuDB. PuDB is a different tool, but it is also a debugging tool, and I think it's worth to know about it. Here I have the same file I've had before. I've shown it before, the same number 2 bits function. And I'm going to use the PuDB tool and use it like this, PuDB foo.py. Now, many people know PDB. I hate PDB so much. It is so annoying. PuDB is a graphical version of that. And it's like a graphical debugger in your shell. So it is very useful when you are debugging something on a computer where you only have SSH access. Okay, so you can now see the interface. It's pretty crazy. I can use it as if it was a debugger like PyCharm, but it's in the SSH session. So it's pretty amazing. I can set breakpoints. I can step through the code. I can do next. I can step in, step out. I can even open a shell. It's a little slow because it's running on my Raspberry Pi. So I'll give it a few seconds. I can open a shell, and I can see the value of variables. And I can run any Python code right inside the process that is being debugged. I can basically do anything, most anything I can do in a real debugger. And the fact that it runs inside the shell with a graphic interface, that's the really amazing part. The most difficult part of working with this tool is that it has keyboard bindings and you have to learn them. You can't use the mouse, as far as I know. So if you press question mark, you see the list of all the keyboard bindings and how to use them. So it takes a while to learn how to use them. And this tool is also, it's not as powerful as PyCharm. I don't think it has multiprocessing support or anything, but it works. It's a cute little tool, and it's worth to know it for these times when you do need it. So that's been PuDB, and I think I'm done. Thank you very much. I hope you enjoyed the talk.
Thank you very much, Ram-san. Yeah, I also still using print debug, print and the logging. So this presentation gave me a lot of motivate to use PySnooper.
Happy to hear that.